Welcome to this lesson, which will look at a conceptual digital twin for urban logistics. The first part of this lesson will explain what we mean when we talk about a conceptual digital twin. We will then look at existing work on the topic and finally define the individual building blocks, which will be explained more in detail in the following sessions. To explain what is a conceptual digital twin, let's recap our definition of a digital twin in general. There we said that we want to have a representation of real physical assets, their behavior and their interactions in a computer-based digital model. And there we were basing our definition on those of wildfire and body. We have already seen this graphic where we basically have physical assets in the real world. We then have a digital twin where we gather data from Internet of Things gadgets, where we run different models and simulations. And then on the other side, we have the urban and city planners, city administrators, business stakeholders, which basically want to interact with this digital twin to find out about new system states in the future, to test new policies, new services, and so on. The centerpiece of this graphic here is the digital twin itself. And so far we only have talked about what a digital twin does, what we can do with the digital twin, but we haven't talked about what are the technical components and how do they need to be connected to actually allow the digital twin to do what we want it to do. So this is what we call the technical architecture, and which is one important part of the conceptual digital twin. We want to know how do we have to set up such a system. The second important component is the business process, because there we basically want to know how are all these elements of the system connected with each other, and especially with the real world where we have the physical assets and the stakeholders which want to have information from the system. And the important question is here, how do the inputs go into the system, either as signals from the physical assets or as data requirements, as research for information from the stakeholders, and how are they connected step by step, sending data from one element to another to the final outputs, which can either be outputs that again go to the physical assets by sending signals to the gadgets and to the devices which are connected to the digital twin, or as reports and information to the stakeholders, which are the final consumers of the modeling results that are provided by the digital twin. During the LEAD project, we have performed literature analysis to understand if there are already any conceptual frameworks for digital twins in urban logistics. An interesting aspect that came out of this literature review, as we see here in this chart, is that the topic of digital twins for urban logistics is a topic that is only gaining an interest in the research community. So we see that most of the publications that we have found come from 2020 and 2021, and only a small share of those papers actually explains the technical basics of the approaches that are presented in these papers. So basically we find that there is so far no attempt in defining a comprehensive conceptual framework for digital twins in urban logistics. However, there are standards in other domains, such as for manufacturing, on which we can base certain aspects of the digital twin and our conceptual framework around them for urban logistics. Let's get back to the individual building blocks that we have just discovered that are part of the conceptual framework for digital twins, because those we will look at in the coming lessons. But let's define a bit better and understand what these individual building blocks want to answer. So first we have the business process, And there we have a couple of questions that we want to answer when we think about what would be the business process of a digital twin for urban logistics. First question here is, what do stakeholders want to do with a digital twin? So what are actually the needs of the stakeholders? What are the information that they want to obtain? What are the systems that they want to steer with the outputs of this digital twin? This we first have to know because these are the questions that we want to answer with this digital twin. And these need to be known so we can find the proper system design. Finally, there's also the question, how do stakeholders want to interact with the digital twin? Because they might want to have reports for a predictive digital twin that are sent to them on a regular basis. They might want to have automatic outputs that can be integrated directly into their system. And all these business cases, they should be covered by the business process. Then we have the technical architecture. And this technical architecture we can define once we know the business process, because then we want to know what we want to do with the digital twin, and we can define what are the technical components that we need to respond to these stakeholder needs. And especially the question is also, how do we need to connect the individual components? Because surely we will need components to store data, then we will need components to run different models. We need components to prepare the results for a report, for instance. So there's many individual elements that need to be connected. And before we actually develop and implement them, we want to understand how should they be designed and also how should the different communication protocols between these elements look like. Finally, although maybe not part of the conceptual part of the digital twin, is the technical implementation. But this process here on this slide should just show that this is all preparatory work before we can actually start to create the code, create the platform, and implement the models that we want to run. So here, once we arrive at the technical implementation, we have to think about which concrete technologies can we reuse to fulfill the tasks that are defined in the architecture. So for each building block, for each different task that we have to define, we need to find a technical solution that we can implement. And once we have searched for all the solutions that already exist to fulfill a certain task, we can think about which are those components that need to be developed on top because they don't exist today and they don't have the features that we want to have on our platform.